Welcome back. This is the very first video on the topic of electronic configuration, and I'd like to keep this very short, probably around 8 minutes or less. The reason being, this is the introductory video to the topic of electronic configuration, but I would like to get through some of the logistics involved on the table that I have designed over the years that has come to work well for me and the students. Now, there are conventional methods that are being used when this topic is done, but I'm trying to change that by putting a different spin on it, and I'll walk you through my method and work out a couple of examples. Now, there's primarily only two types of domains that you have to worry about. Okay, that's domain one. Now, I'm calling it domain one. Somebody else teaching it somewhere else in the world might have a completely different name. Okay, domain one, that primarily deals with elements in row 1 through row 3. So you have one set of rules that governs elements in domain 1, which are primarily in row 1 through 3. And then you have domain 2, which have a slightly different set of rules, I should say one set of rules that governs elements in row 4 and beyond. I wish my chemistry teacher in high school, or at least in earlier years of my college, had mentioned this and made life easy by saying there's really only two kinds. Well, life would have been simple. But no, it took me just so many years just to figure out, hey, there's probably a better way to do this. So you probably won't find a figure like this. You'll find conventional figures, which you will see in the next video on Google. You're welcome to use that if that fits your imagination. But here's what I recommend you use because it works well with the periodic table I've given to you in the class. All right. Now, the way I have structured it is all elements have one s orbital. We've already talked about orbitals s, p, d, f. It doesn't matter it's 1s, 2s, whatever, which you will see now. S can hold a maximum of 2, p can hold 6, D can hold 10, and F can hold 14. This is max, okay? That doesn't mean that every time you come across an element that you have to meet this requirement. That's the whole purpose of an electronic configuration, is how is this spread out? Now, if you see that, follow my arrows. You start with 1s, so both these elements have 1s, and then you come down to the second row. You start with 2s for these two elements. They both have 2s, and you go across the border, and then you get into these 5 elements. They all have 2p. They're in the 2p window. Think of it that way. These two are in 2s window. These 5 are in 2p window. And then the sequence continues to 3s, where you have these 2 elements in the window, and then you go across, and then you have these 10 elements that are in the 3D window. And then you get to, 3s, and then you go to follow the arrow, and then you get to 3p window, 5 elements, right? Because there's nothing here. These are just letters, that don't get them confused. So 3s window, and then you go to 3p window. And you come to 4th row where these 2 elements are in 4s window, and then these 10 elements are in 3D. Now we will do something called flipping, and that's what I meant by one single rule is flipping. Okay, I have made a separate video just dedicated to domain 2, so I'm not going to get into that here. Okay, so you got 4s window, 3D window, and then you got these 5 elements in 4p window, and then you got these 2 elements in 5s, and then you got these 10 in 4D, these 5 in 5p, then you got these 2 in 6s, and then you got all these elements which are just shoved in here under 4f. So you basically have a 4f. I don't really know if I have many examples this far, maybe one at best. So 4f. And then you have these elements. I believe there's 9 that are part of 5D. And then you've got these 5 under 6p. As I said, I think I may have one at best that may cover this far, but mostly I like to restrict myself with 5 because of this little jump confusion. But it's not confusing, but it's just something you may want to watch out for. So you got the 6s, 4F, and then 5D, and then 6D. Now, as I said, the first 3 rows fall in domain 1. They're easy to work with, super simple. And I'm going to do a couple of examples just demonstrating domain 1. I've dedicated a separate video for domain 2 where I've clearly explained how to go about doing the flipping process. Okay, it's not tedious, but if you follow that method, you're going to get it right every single time. Now, that's not how is it explained in the textbook. Probably not. Okay, so you can watch that video. So let's do maybe an electronic configuration for fluorine. Okay, well, where do you get the amount of electron information? From the atomic number. It's 9, so we have 9 electrons, right? So you start with 1s. So don't write 1s, 1s. What it really means is you have the first row, both elements are in the 1s window. So you write 1s only once. You don't ever write any of these more than once. You only write them only once in the entire sequence. So to get to the 2p window, you have to bypass 2s. So 2s, and then, well, I'm in the 2p window, which is where fluorine is. So I stop right there. And I start filling electrons from left to right. And I fill the maximum except for the last one, because I'll show you why. So I have 9, s can hold 2, this s can hold 2, and I stop. Okay, I give all orbitals but the last one the full count, which is 4. And I have 9, right? So 9 minus 4 is 5. So this is 2p5, and that's it. If you follow this method, you're going to get it right every single time. Let's do one for in the third row. Let's do sulfur. Okay, sulfur is 16, which is in the 3p window. So we got to get through all these windows before we can get to sulfur. So 1s once, 2s once, 2p once, 3s once, and 3p. Well, I've achieved the 3p window, which is where sulfur is located. I start filling all orbitals with their maximum number of electrons except for the last one. So 2, 2, 6, 2. And if you see, I'll be left with 4 because 16 minus 12 is 4. And that's how you do domain 1 configuration. I have dedicated a separate video just for domain 2. So please do watch those. And I like to wrap up the intro video at this point, and I would want you to continue watching the remaining videos. They're all very crisp, to the point, so you should not be wasting any more time on any particular video than you really had to. All right, so stay tuned.